Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is the part 1 video on the next chapter of polygons, where I will discuss about what are polygons, the sides and angles of polygons, and some properties and formulas of polygons, especially irregular polygons. So this I will not solve any problem in this part. Mostly it will be theoretical. I will discuss about all the the definitions and some properties of polygons. In the next video, I will solve the first exercise of this chapter from the textbook of author RS Aggarwal, that is exercise 14A. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 1 video on the chapter of polygons. Okay, so I have prepared my rough notes. It is incomplete of about polygons that I will discuss in this video. It will be mostly descriptive, so no problems will be solved. So it could be a bit of boring, but please bear with me. It is important to know what exactly are polygons and their properties. So let's begin. First of all, let's build the foundation to understand what is a polygon. We need to understand first few other things. The first thing we need to understand is a curve. What is a curve? Now, the definition I have taken straight away from the textbook of author RS Aggarwal. I will read them and then I will try to explain the geometrical. These are all geometrical concepts using some example figures. So what is a curve? A figure traced out on a plane surface with a sharp pencil or pen without lifting it. So if you are drawing, so a figure traced out on a plane surface. On a plane surface means on a piece of paper. If you draw the curve, if you draw using freehand, if you draw with a pencil or a pen of a figure. Now figure, what is a figure? A figure is a continuous connection of points. So I'm drawing. Now on the left hand side, as you can see, there is a vertical line. On the left hand side, I will draw some curve, valid curves on the right, and on the right hand side, I will draw some figures which is not a curve. So on the left hand side, this is a curve. I did not while I was drawing, while I was tracing out this figure, I did not lift my pen or my stylus. Similarly, this is a figure. 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 So as you can see, it's a continuous points, that is a trace, and I have drawn the figure without lifting the pen, or even without lifting the pen, without lifting a pen without lifting the pen. So it is a continuous. So this is the curve, a figure. Now what is the figure? A figure means a two-dimensional shape. Two-dimensional shape. Now why two-dimensional? Because we are drawing the figure on a plane surface. Now on the right hand side, if I say that let's say I am drawing a figure, I have this, I can draw, this is a figure, this is a rectangle, this is a figure, but the moment let's say I draw a circle on top of it, now this whole thing, is this a figure? No, this is not a figure, because I cannot draw the circle. Once I have completed drawing the rectangle, I have to lift my pen to draw the circle. So these as a whole is not a figure. But individually, if you think of the small circle and the rectangle, they are individually they are curves. Sorry, they are curves. But this whole figure is not a curve. On the left hand side, all the figures that I have drawn, they are all curves because I have drawn them without lifting the pen. Let's say I am drawing a figure. Let's say and then I lifted my pen and then I draw something like this. So this is not a figure. This is not a curve. Sorry, this is a figure, but this is not a curve because I lifted my pen. As you can see, there is a broken part. I had to lift my pen. After drawing this part, I had to lift my pen to again draw this part. I hope you are getting the idea. So now quickly let me draw some figures which are not curved. As you can see, let's say this is not a curve. Sorry, this is a curve. This is a curve because I can easily draw this even though there is a broken part, but I can draw this figure without lifting my pen. So this is a curve. Sorry. Let's say this is not a curve, so I had to lift my pen. Okay, so I hope it is clear what is a curve. A curve is a figure that is you now what a figure. Now what is a figure? A very continuous connection of points. Now or you can say lines. Now that not line but continuous connection of points. Now the line could be straight or it could be curved. Yeah, I can possibly say a continuous line which could be a curve, which could be curvy or it could be a straight. So that is a curve. That is a figure you draw without lifting the pen. Okay. Now what is an open curve? I will quickly check whether everything is visible or not. Okay. Now what is an open curve? Similarly, as usual, I will draw some valid correct open curves on the left hand side, and I will draw some curves on the right hand side which is not open. Now what is an open curve? The definition says a curve that does not end at the starting point. So as you can understand, when you are drawing a curve, you start on the plain paper. You start from a specific point. You draw the figure, and then you end at a specific point. Let's say I am drawing this figure. Let's say I am drawing this figure. This figure I have drawn. So clearly, this point was the starting point and this point was the end point, and you see that the end point and the starting point are not the same, So whenever you draw a curve, when the end point does not coincides with the starting point, then it will be an open curve. Other examples are you can say this is also an open curve. As you can see, this was the starting point and this is the point where I ended when the curve I finished drawing the curve. So this is an open curve. As the point A, the starting point A, I am referring the starting point as A and the end point as B. So A and B do not coincide. Other examples could be, let's say, I am taking some examples from the book. This. So this was the starting point and this is the end point, and they are not the same. When the end point, so what is an open curve? A curve where the end point is not the same as the starting point. That is, that is, the curve is not completed by that is a curve that does not end at the starting point. So as you can see, when you draw a curve, there is a starting point and a end point. And if they are not the same, then it will be an open curve. Some other examples could be this is an so let's say, so this is also an open curve. This was my starting point and this is the end point, and as you can see they are not the same. Let's see some other examples. Let's say this is also not a, this is also an open curve, as this was my starting point and this is my end point, and they are not the same. Now definitely, let's say, like, now let's try to draw some curves which are not open. Now on a curve which is not open automatically means it is a closed curve, which I will discuss, which is the next point. So what is when a curve is when do we say that a curve is not open? When the end point and the start point, they coincide, they are the same. So let's first try to understand what is a closed curve. A curve that ends at the starting point, that is the end point and the starting point, they are same. So let's draw some closed curve. This is a closed curve, as this was both my starting point and end points. From the point A I started, and then I draw this side. This is a triangle. I draw this side, and then I draw this side, and finally I draw this side. And while drawing this side, I when drawing of this side was completed, the ending point was B, which is basically coinciding with the starting point A. Similarly, let's say uh, mm, let's say mm, this is also a closed curve, as this point is both the starting point and end point. I started from this point and I draw the curve. I'm using some arrow, even though a curve should not have any arrow. Just for the sake of explanation, I draw the curve this way. This was my path of drawing the curve, and finally I ended at the same point, at the starting point A. So this is also a closed curve. Let's draw a few other examples. So let's say this will be my starting point A. Okay, I will draw. Let's say I'm trying to draw a star. I'm trying to draw a star without lifting the pen, obviously, since it will be a curve, and I will end at the point A itself. Sorry, I messed it up. How can I draw a star? Let me see. This. Okay. More or less, even though my drawings are not perfect, I hope you're getting the idea that I started from the point A, I drew all the sides, and then I ended in drawing the curve by my ending point was again the point A. Let's see. Okay, so let's say this is my starting point. I am drawing now. This time I will use some lines. So this. So this is also a closed curve, as both the starting point and the end point are the same. That is, I ended this curve of this curve ended at the starting point only. Okay. Now obviously any curve which is not closed will be open curve, which I have already drawn in the previous section. That is, what is an open curve. I hope it is clear what is an open curve and what is a closed curve. let's try to draw some curves which are not closed. So this is not a closed curve. I started from this point A and I ended at the point B. Now, one thing to note is that, okay, I will discuss that later on. So this is not a closed curve. On the right hand side, this curve is an open curve. What else? So again, let's say this is also an open curve. It is very obvious. I started from the point A and I ended at the point B, and they are not the same. They are different points. So if the starting and the end points of a curve drawn are different, then it is an open curve. And if they are the same, then it is a closed curve. Okay. Next thing is, what is a simple closed curve? Now, a simple closed curve is a closed curve that do not intersect with itself. Okay. Similarly, as usual, I will try to draw some valid simple closed curve on the left hand side and some invalid simple closed curve on the right hand side. So, okay. So a closed curve that do not intersect with itself. So the curve, it is a, first of all, it is a closed curve. So the starting point and the end point will be the same. But while you are drawing the curve, in the process or in the midway of drawing the curve, you should not pass through a portion of the curve that is already drawn. For example, now let me first draw some closed curve which are not simple. That is, they intersect with itself. So this curve, first of all, it must be a, okay. So what is a simple closed curve? It is a closed curve, but it should not intersect with itself. Okay. Now, first, I think it will be easier to first understand what it means by saying that a curve intersects with itself. Okay. So this curve is intersecting itself. So I started at the point A and I ended at the point B. Obviously, since the starting point and the end points A and B are different, it is obviously not a closed curve. It is an open curve. But at this point, the curve intersects itself. So this is definitely not a closed curve, but it is also not a simple curve, as this curve is intersecting with itself. Some other examples could be a star. So let's say I'm drawing a starting point is A. I'm trying to draw a star. So this, now this is a closed curve. This is a closed curve as both the starting point and the end point are the same. This is both the starting and the end point are the same, but the curve intersects itself at various points. This C1, I am denoting C as the point of intersection of a curve with itself. So C1, this was a point of intersection, that is, the curve is intersecting with itself. This point is another point of intersection. This point is another point of intersection. This is another point of intersection, and this is another point of intersection. So there are 5 points of intersection. So there are 5 points at which the curve is this curve this is a closed curve, but it is intersecting with itself. Since it is a closed curve, but since it intersects with itself, it is not a simple closed curve. So I hope it is clear what is meant by a curve that intersects with itself. Let me see to draw. Okay, so this is also a curve that intersects with itself. So even though I started at the starting point and the ending point are the same, this was the starting and ending point, but the curve intersects with itself at this point C. This is again, so I will draw a curve with A. This is the starting point. So this is a curve. As you can see, I started at the point A and I also ended at the point A. So the ending point, starting point and the ending point of this curve is the same. So this is a closed curve, but it is not a simple closed curve because this curve intersects with itself at 4 points. These 4 points. This is the one point of intersection that is intersecting with itself. This is the second. This point is the third point of intersection, and this point is the fourth point of intersection. So this is not a simple closed curve. It is a closed curve, but it is not a simple closed curve. Now let's see what is a simple closed curve. A triangle, the simplest simple closed curve is a triangle. This is a simple closed curve. It is a closed curve because this figure, the triangle was drawn where the starting and the ending point was the same, AB. This was the starting and ending point, and as you can see, the curve does not intersect itself anywhere while it was drawn. Okay, this curve is again a closed curve. I started and ended at this point, and as you can see, there is no point at no point the curve intersect with itself. Okay, again this is a simple closed curve. This point was the starting and ending point. I hope you are getting the idea. What is a simple closed curve? Again, a square is a simple closed curve. This was my starting and ending point. A rectangle is a simple closed curve. This was my starting and ending point. So at no point, all the curves on the left hand side, at no point they are intersecting with itself. So this is a simple closed curve. Now we will see what is a polygon. A polygon is a simple closed curve formed by line segments. It is a closed curve, but it is formed by multiple line segments. Now, one thing to note is that now if you give a little bit of thought, you can see that a polygon is a closed curve. It is a simple closed curve. That is, it is a closed curve and it will not intersect with itself. That is why it is a simple closed curve, and it is formed by few line segments. That is, by joining few one or more few multiple line segments. Now, if I have let's say if I have two line segments, this is definitely not a this curve is formed by line segments. Let's say AB is the one line segment, and BC, let's say, is the another line segment. So this figure, this is a curve formed by two line segments AB and BC, but it is not closed. It is not closed. So definitely we cannot, as you can see, using two line segments, we cannot form a polygon, because using two line segments, it will never be closed. So to have a closed curve that is formed by line segments, you must have at least three line segments. Now you can see, if I join, so I drew this curve. I first draw the line segment AB. From A to I draw the line segments AB, and from B I draw the line segments BC, and then if I draw the line segment CA, I now form a simple closed curve, and it is formed by the line segments AB, BC, and CA. So the thing is that you need at least three line segments to form a polygon. With two line segments, you cannot form a polygon. So three line segments are minimum are required to form a polygon. Let's see some other examples of polygon. So okay, now let's see how we can draw some polygon using four line segments. One, the simple, so this is a polygon with, even though my figures I am drawing with hand, so the lines may not look like a line segment straight, but please assume that they are straight. So this figure is definitely a polygon formed by the line segments AB, BC, CD, and DA. Okay, now let's see some other polygons. This is also a polygon. So the line segments, as you can see, so in the triangle, now each line segments that forms a polygon, they are called the sides. In the first diagram, the triangle ABC, the line segments AB, BC, and CA are called the sides of the polygon. So these are the sides of the polygon. These are known as the sides of the polygon. That is, the line segments that are forming the polygon are known as the sides of the polygon. So in the last figure, if you and the corner points are known as the vertex. So in the first figure, it is where we are having a polygon of three sides. A, B, and C are the vertices, or the vertices of the polygon. There are three vertices. There are three sides and three vertices. In the second figure, there are four sides and four vertices. Okay. In the last figure, let's say if we now how do we name the now what exactly are the vertices of the polygon? Two sides, as you can see, if it is a polygon, the point at which two adjacent sides meet, that is a vertex of the polygon. The sides AD, in this figure, the side AB and the side AB and BC, they are adjacent sides, and they are having the common end point B. So B will be a vertex of the polygon. Similarly, for the sides BC and CD, the adjacent sides BC and CD are having the common point C. So C is a vertex of the polygon. So this way we define the vertices of the polygon, and as you can see, the number of sides is equal to the number of vertices of the polygon. Now in the last figure, let's say the vertices are A, B, C, D, E, F, G, H. As we can see, the sides are AB, BC, CD, DE, EF, FG, GH, and HA. These are the line segments that is forming the polygon, and these are the sides of the polygon. And definitely the vertices are A, B, C, D, E, F, G, and H. Okay, I hope it is clear what is a polygon. So a polygon is a simple closed curve. It is formed by connecting line segments, and each line segment is known as the side of the polygon. Now, what are angles of the polygon? So the angle made by two adjacent sides is an angle of the polygon. So this is for the triangle. This is one angle of the triangle of this polygon. Now, since we know you have already studied triangle, so this is basically a triangle. This is another angle of the polygon or the triangle, and this is the third angle of the polygon or triangle. Now, as you can see, the number of angles in a polygon is equal to the number of vertices of the polygon. Since at each corner points of the vertex we are having an angle. For the second figure, this is an angle of the polygon, this is an angle of the polygon, this is an angle of the polygon, and this is an angle of the polygon. Now these angles that I have marked, these are actually interior angles of the polygon. Now there is a concept of exterior angles of a polygon which I will discuss in the next section, but these are as I have marked, these are interior angles of the polygon. Okay. Now let's see what are exterior and interior angles of a polygon. Now I have drawn some figures. I will show what are the exterior and interior angles of these polygons. The exterior angle I will show with the green color, and the interior angles of the polygon I will show with a purple color. So let me first draw. Let me number the figures. Let's say this be figure number 1, this be figure number 2 or polygon number 2, this be polygon number 3, this be polygon number 4, and this be polygon number 5. Now I am showing what are the exterior and interior angles of a polygon. So as you can clearly understand that for the polygon number 1, these are the interior angles. Let me quickly color them. So these are the interior angles of the polygon, which is basically a triangle, as you know. Now there is another thing that I have skipped, is that since we have understood what is a polygon, so basically a polygon is formed of some number of line segments which are known as the sides. Now based on the number of sides of a polygon have different names. Now I will not write, I am just discussing, I am just saying you can refer your textbook. So as I have already said that the minimum number of sides a polygon can have is 3, which is a triangle. So a polygon having 3 sides is a triangle, a polygon having 4 sides is a quadrilateral, a polygon having 5 sides is a pentagon, a polygon having 6 sides is a hexagon, a polygon having 7 sides I guess is a heptagon, a polygon having 8 sides is octagon, a polygon having 9 sides is a nonagon, and a polygon having 10 sides is a decagon. Okay, mostly you will deal with triangle, which is a polygon of three sides, a quadrilateral, a polygon of four sides, and maybe pentagon, pentagon or hexagon. Okay, so for the polygon number one, these are the interior angles. Now, what are exterior angles of this uh, polygon, which is a triangle? I think you are from your previous class, class 7. You are already familiar with the exterior angles of a triangle. Okay, so how do we figure out the exterior angles of this polygon number one, which is a triangle? So we extend one side. So let's say I am extending the side AC like this to the point D. So this is one exterior angle. So I've extended the side AC to the point D, and that's the now the straight line DC. Whatever angle BA is making, the line segment BA is incident on the line segment DC, and this angle is one exterior angle. This is one exterior angle. Let's draw another exterior angle. Now if I extend the side AB to the point E, this angle is another exterior angle. This is another exterior angle. Similarly, if I extend the side BC to the point F, then this angle is another exterior angle. This is the third exterior angle. Now, it must be obvious that, so how many exterior angles are there in a polygon? As we have already understood that there are, how many interior angles are there in a polygon? There are as many vertices are there. So for a triangle there are three vertices. We have three interior angles. For a quadrilateral there are four vertices, there are four interior angles. Now I think the number of interior angles is also the same as the number of sides of a polygon. So you can say that so we know that the number of interior angles in a polygon is equal to the number of sides of the polygon. Now, how many exterior angles will be there? As you can see that we extended each side of the polygon to form an exterior angle. So definitely the number of exterior angles will also be equal to the number of sides of the polygon. Okay, so we can say that the number of exterior angles is equal to the number of interior angles of a polygon. Okay, so that was the polygon number one, which was basically a triangle. Now let's see what are the exterior and interior angles of polygon 2, which is basically a square. So obviously, yeah, as you know, since even though it might not look like a square, but I was trying to draw a square, let's assume it is a square. The polygon ABCD is a square. So all the interior angles, these are the interior angles, they are all 90 degree. They are 90 degree. So where is my color? Okay, so these are the interior angles. Which are, since this polynomial is a square, we all know that the interior angles of a square are right angles, that is 90 degree. Okay, now what are the exterior angles of this polynomial 2, which is a square? So if we extend the side AB, let's say to the point, sorry, not, if we extend the side AB to the point F, then this angle is the exterior angle, which is also a will also be a 90-degree, since we know that the side AD is perpendicular to the side AB, and AB has been extended to F. So definitely the angle, the exterior angle, which is angle DAF, is also a right angle, that is 90-degree. So this is an exterior angle. Now let's see, draw the next exterior angle. If we extend the side AD to the point EFG, then this angle is the exterior angle, which is also 90-degree. Okay, let's see the next exterior angle. If we extend the side DC, if we extend the side DC to the point H, then this angle is the exterior angle, which is also a right angle, that is 90-degree. Similarly, if we extend the side CB or BC to the point I am extending the side CB to the point I. So this is the exterior angle, which is also 90-degree. So for the polygon 2 of sides, number of sides 4, which is basically a square, we are having all the interior angles is 90-degree, and all the, so it has 4 interior angles and 4 exterior angles, and since it is a square, all the 4 exterior angles are same, they are 90-degree. Okay. Now I think the polygon 3 and 4, they are quite same. So I will do only polygon 4. Okay. Let's draw the internal angles. Give some names to the vertices. Let's say A, B, C, T, and E. So the interior angles, obviously, it is very obvious and clear. These are the interior angles of this polygon having 5 sides. Okay, so these are the interior angles. Now, you might be thinking that if the sides of a polygon are equal or of same length, then maybe all the interior angles are same. And if you are thinking so, you are right. And also in that case, all the exterior angles will also be same. We will discuss that a little later. So these are the interior angles of this polygon number 4. Now let's see what are the exterior angles. I will extend the side AB to the point F. So this angle is a exterior angle. This is an exterior angle. Sorry. This is an exterior angle of this polygon. Okay. Let's see what is the next exterior angle we can draw. I am extending the side AE to the point G. So this angle is the exterior angle. This is another exterior angle. Okay. Now let's draw the next exterior angle. I am extending the side ED to the point H. So the exterior angle formed is this angle. This is the exterior angle formed. Okay. Now I will let's see what is the next exterior angle. I will extend the side DC and extend it to the point I. So this is the next exterior angle. Okay. And the last one will be, since the only side CB is left, I am extending the side CB to the point J. So this will be the exterior angle, this angle. So as you can see, for this polygon 4, there are this polygon has 5 sides and we are having 5 internal angles and 5 exterior angles. So for a polygon of n sides, we have always have n number of polygon of n sides, we always have n number of interior angles and n number of exterior angles. Now for the polygon 5, I think there will be some difficulty in drawing the exterior angles. Now exterior angles, also exterior angles. Okay. Now let's see what is the interior angles. What are the interior angles? Definitely, let's give some name first of all to the vertices. Let's say this figure polygon is A, B, C, D. Now clearly this is one interior angle, this is one interior angle, this is one interior angle, and the last interior angle will be this. As you can see, this is a little weird. It is greater than 180 degree, but that is the interior angle. So let me quickly highlight the interior angles. Since this polygon has how many sides? 1, 2, 3, 4, 4 sides. We are having 4 interior angles. As you can see, 3 interior angles are less than 180 degree, but this interior angle, this one, it is more than 180 degree. So these are the interior angles of this polygon. Now let's see what are the exterior angles. I am extending the side AB to the point E. So this is the exterior, this is an exterior angle. Okay. Now it will be problematic to draw. Now if I extend the side AD, I am not sure what will be the exterior angle if I extend the side AD. If I extend the side DC, let's first draw all the exterior angles that are easy to draw. If I extend the side DC up to the point F, then I can say the exterior angle formed is this angle. This is the exterior angle formed. This is the exterior angle formed. Again, if I extend the side extend the side, this was point C, CB, if I extend the side CB up to the point G, I have the exterior angle formed is this angle. So this is another exterior angle. Now the problem is when I extend the side AD, I have no idea how to draw the exterior angles. So probably, I'm not sure, probably this is my guess, for a polygon where one interior angle is more than 180 degree, as you can see, the sides AD, the sides AD and DC of this polygon is making an angle which is more than 180 degree. For that, the exterior angle will be possibly, it is not possible to draw the exterior angles. I'm not sure. So in a polygon where a polygon having n sides, if there are one or more interior angles which is greater than 180 degree, I don't know how many exterior angles are there. Obviously, the number of interior angles will be n. If the number of sides of the polygon is n, then the number of interior angles will be n. But if there are some interior angles, one or more, are greater than 180 degree, then what will be the number of exterior angles? I don't know. If you know, then you can let me know in the comment section. I will highly appreciate that. Now the next concept is, what is a concave polygon? Now we have a concave polygon and a convex polygon. This is related to the measure of the angle of an interior angle of a polygon. So what is a concave polygon? The polygon 5, as we draw, this was a concave polygon. So what does the definition say? A polygon having at least one interior angle more than 180 degree. A polygon having at least one interior angle more than 180 degree, then it is a concave polygon. As you can see that, let's try to draw another concave polygon. So definitely one interior angle is at least one interior angle is more than 180 degree. So let's say we are drawing two sides so that they are making an angle of more than 180 degree, two adjacent sides of the polygon. So let's say this is one sides and this is another sides. So let's say this is A, B and C. So these are the two adjacent sides of a polygon. We have not yet completed the polygon. We will do so. Now let's complete the polygon. So definitely, as you can see, this angle is more than 180 degree. A polygon can so what is a concave polygon? A polygon having at least one interior angle more than 180 degree. It can have more than one interior angle which are more than 180 degree. So let's draw another interior angle which is more than 180 degree. So obviously for that we need to have another two adjacent sides. Let's say another two adjacent sides which are making an angle of more than 180 degree. So this is this angle is also more than 180 degree. So we can say that this could be the, sorry, please don't mind, my drawing is very approximate. The lines may not look like straight, but so EF, so this is, let's say this is the polygon. G. So how many? So this is the polygon. So how many sides are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides. So this is a polygon having 8 sides, and obviously two interior angles are having more than 180 degree. So it is a concave polygon because it is hardly having at least one interior angle more than 180 degree. All other interior angles are less than 180 degree. So I hope it is clear what is a concave polygon. Let me quickly draw few other concave polygon. This is also a concave polygon, as this angle, this interior angle is greater than 180 degree. So I think it is clear. I did not draw any further more concave polygon. So a concave polygon will be a polygon where it is having at least one interior angle which is more than 180 degree. And what is a convex polygon? Just the opposite. Convex polygon, that is a polygon having all interior angles less than 180 degree. So all the interior angles must be less than 180 degree. Then it is a convex polygon. Examples are this is a convex polygon. These are all convex polygon, as all the interior angles are less than 180 degree. Remember, it is less than 180 degree. It cannot be 180 degree. I mean, an interior angle of a polygon cannot be a 180 degree, because then two sides will coincide and become one side. Okay, so this was concave and convex polygon. Now is the most important part, which is a regular polygon. Now, what is a regular polygon? So definitely a regular polygon is a polygon, and also the definition says that a regular polygon is a polygon having all the sides of equal length and also all the interior angles of equal measure. So a regular polygon is a polygon where all the interior angles are equal and all the sides are equal, of equal length. If you think, then you will see that such a kind of regular polygon will obviously be a convex polygon. So I will try to draw, since I am drawing by freehand, it may not look exactly like a regular polygon. I will try. So the first one is definitely the simplest one. The simplest regular polygon is a equilateral triangle. So this is a equilateral triangle. This is a polygon definitely. This is an equilateral triangle where all the angles are same. We know that in an equilateral triangle all the angles are same. So in this, if we consider this as a polygon with n sides, definitely all the sides are equal and also all the interior angles are also same. That is, it is 60 degree. Similarly, for a square, so this is the next a polygon, a regular polygon of side 4 is a square, and a regular polygon of n, I am considering n as the side of number of sides of the polygon. So n is 3 and this is n is equal to 4. So whenever a regular polygon of side 4 means a square. Okay, so we know that all the interior angles of a square are 90 degrees, so they are equal, and also all the sides of the polygon or the square are same. Okay, so this was two regular polygons of sides 3 and number of sides 3 and 4. So what will be a regular polygon of sides, number of sides 5? It will be a pentagon definitely. Let me try. I'm not sure whether I will be able to draw it properly or not. Maybe, I don't know. So this is a regular polygon of sides, number of sides 5, and where all the interior angles are same. And also, if it is not looking, please assume that all the sides are same. That is, x degree. All the interior angles are x degree, whatever the value of x is. All the interior angles are x degree. And also all the sides are equal. All the sides are equal. So this way you will have hexagon and nonagon and heptagon this way. Okay, so this is a regular polygon. That is a polygon where a convex polygon, as you can see, all regular polygons will be convex polygon. So a convex polygon where the number of where all the sides are of equal length and all the interior angles are of equal measure. Okay. So finally, we will study some formulas, or you can say properties of polygon having n sides. So these are some properties. Some properties will be in general for a polygon of n sides, and some will be in general for some convex polygon, and some will be for specifically for regular polygons. Okay. So the number of diagonals of a polygon of n sides is equal to n. If n is we are considering, assuming the polygon is having n number of sides, then the number of diagonals will be equal to n into n minus 3 by 2. Now what are diagonals of a polygon? What are diagonals? If you have, let's say this is I'm drawing a polygon, not a regular polygon. Let's say this is a polygon A. Let's say name the polygon as A, B, C, D. So this is a polygon having 4 sides. Now what are the diagonals? This is a diagonal. This is another diagonal. That is, you take a vertex and then you connect all other vertices, all other vertex by a line. So for this polygon, it is having 4 sides. Now let's discuss here only. Polygon having n sides, it is saying that the number of diagonals will be n into n minus 3 by 2. So let's take some examples. Let's say this is a polygon of number of sides n is equal to 4. 4. So the number of polygons, I'm abbreviating the number of polygons, let's say, as the number of diagonals, as NOD. I'm abbreviating the number of diagonals with NOD. So for this polygon having number of sides n is equal to 4, NOD will be 4 as per the formula n into n minus 3 by 2. 4 into 4 minus 3 by 2, which is equal to 2. As you can see, there are 2 diagonals, this and this. Interestingly, for a triangle, there are no diagonals. If you consider a triangle, you will see that triangle, the number of sides is 3, and so the NOD, the number of diagonals, is equal to 3 multiplied by 3 minus 3 but divided by 2, which is 0. So for a polygon having 4 sides, that which is known as a quadrilateral always have 2 diagonals. Now you can consider, let's say, a polygon having 5 sides. 1, 2, 3, 4 and 5. So over here n is equal to 5. So the number of diagonals will be 5 multiplied by 5 minus 3 divided by 2. This is equal to 5. Let's see if we can have 5 diagonals in this polygon having 5 sides. So this is one diagonal, this is another diagonal, this is another diagonal, and this is, we have so far drawn 3 diagonal, 1, 2, 3 diagonal. This is fourth diagonal, and this is fifth diagonal. So we are having 5 diagonals. So remember that in a polygon having n sides, the number of diagonals is equal to n into n minus 3 by divided by 2. Okay, this was property number 1, which is based on a general polygon having n sides. Property 2 is for convex polygons. This is for convex polygons. These properties will not work for a concave polygon. This is only for a convex polygons. So in any convex polygons, in any convex polygon having n number of sides, the sum of exterior angles is always equal to 360 degree, irrespective of the number of sides of the polygon. As you can see, so this is important, that the sum of the exterior angles of a convex polygon is always 360 degree. And the sum of the interior angles, is equal to n minus 2 multiplied by 180 this much degree. So basically the correct way of writing is this: whatever the value is this much degree, n minus 2 multiplied by 180 this much degree is the sum of all the interior angles of a convex polygon. Now why for a convex polygon the sum of the exterior angles is 360 degree, I do not have a proof, that I don't know how to prove it. But if you draw some figures, some polygons, for triangle you already know that the sum of the exterior angles is 360 degree. In the properties of triangle in your previous class 7, you should have already, you already know that. For a square also, for a quadrilateral, that is a polygon of having 4 sides, if you consider a square, you will see that all the exterior angles are 90 degree. So 90 into 4 is 360 degree. Now if you in general consider a quadrilateral, that is a polygon having 4 sides, if you give some specific values to the interior angles, you will see, okay, let's try it. Let's try to see whether these formulas are correct or not. That is, the sum of all exterior angles of a convex polygon, irrespective of the number of sides, is 360 degree, and the sum of all the exterior angles is 360 degree. It is not dependent on the number of sides of the polygon. Whatever the value of NB, that is the number of sides, the sum of the exterior angles of a convex polygon will always be 360 degree. And also the sum of the interior angles will be, it is dependent on the number of sides n, and so the sum of the interior angles will be n minus 2 whole multiplied by 180 degree. Let's quickly see whether this is true or not for a polygon of side 4. Let's say, I will draw roughly. Let's say this is having, let's say, this angle. Let's say this angle is 110 degree. Okay. Now let's say this angle B 70 degree. Okay. It will be difficult because 1, 2, 3. What will be this angle? No, sorry, I don't think I will be able to demonstrate with an example. I'm really sorry for this, but please know that for a convex polygon having n sides, the sum of the exterior angles is always 360 degree. That is, it is independent of the number of sides of the polygon, but the sum of the interior angles is n minus 2 whole multiplied by 180 degree. Now specifically for a regular polygon of number of side n, each exterior angle as I have already explained, we have already discussed that for a regular polygon, all the exterior angles are equal and also all the interior angles are also equal. So if we know that and also a regular polygon is also a convex polygon. So we know for a convex polygon that the sum of the exterior angles is 360 degree, and we know that if it is a regular polygon, then all the exterior angles are equal. So definitely each exterior angle has to be 360 divided by n. So this is for a regular polygon, the measure of each exterior angle is equal to 360 degree divided by n. That is the number of sides. Also, then each interior angle will be equal to 180 degree minus each exterior angle. Now, for a regular polygon also, as you know, we have discussed that each interior angles are also equal. What will be the value of value of each interior angle? It will be 180 minus the value of each exterior angle. Now, each exterior angle we have already seen, it will be 360 by n. So each interior angle will be 180 degree minus 360 by n, which if you simplify, it comes to this formula: n minus 2 whole multiplied by 180 divided by n. This much degree will be the value of each interior angle of a regular polygon of number of side n. Now, one thing I forgot to say about how the exterior angles and interior angles are connected. So over here, as you can see, let's consider the polygon number 1 triangle. As you can see, the two adjacent interior and exterior angles, the sum of them is 180 degree. That is how we draw all the exterior angles. For drawing the exterior angles, first we extended the side CA. We extended the side CA to the point D, and we got this exterior angle. And as you can see that this exterior angle and these interior angles, they are on the same side of a line segment. That is the segment BA is incident on the line segment CD. So definitely the sum of the exterior angle and the interior angle will be equal to 90 degree. This is some property of triangle. So all the sum of all the adjacent interior and exterior angles, you will see their sum is 180 degree. Hence, we are using that concept here while finding the value of each interior angle. We know that an interior angle, since for a regular polygon all the interior angles are same, and we know that the sum of an exterior angle and the interior angle is equal to 180 degree. So definitely we can say that an interior angle will be equal to 180 degree minus an exterior angle, and hence we get the formula n minus 2 whole multiplied by 180 divided by small n. Now, two quick results based on the exterior and interior angles of a regular polygon. In a regular polygon, as you can see that the minimum number of sides of a regular polygon is minimum number of sides of a regular polygon is 3. And also not regular polygon, the minimum number of sides of a polygon is 3. And so obviously for a regular polygon, the minimum number of sides for a regular polygon will also be 3. So what will be the maximum exterior angle in a regular polygon? Maximum exterior angle. So what will be the number of sides? So based on since we know that each exterior angle of a regular polygon is dependent on the n, the number of sides, because its value is 360 divided by n. The value of each exterior angle of a regular polygon is 360 divided by n. It is dependent on n, the number of sides of the polygon. Now, if you apply some common sense or logic, the value 360 by n will be a maximum when the denominator is a very small number, is the smallest. And we know that the smallest value of the n, that is the number of sides, is 3. So 360 divided by 3, which is 120 degree, will be the maximum exterior angle of a regular polygon. That is the exterior angle of a polygon of having 3 sides. So remember that the maximum exterior angle of a polygon is 120 degree, and also the minimum interior angle will be when the exterior angle is maximum. That is, so in that case, the minimum interior angle will be 180 degree minus the maximum exterior angle, and the maximum exterior angle we have seen, we know is 120 degree. So the minimum interior angle is 180 degree minus 120 degree, which is 60 degree. So this maximum exterior angle and minimum interior angle happens for a polygon of 3 sides, which is for a regular polygon of 3 sides, which is a triangle, and specifically it is an equilateral triangle. So we know that the interior angles, the angles of an equilateral triangle are all same, which is 60 degree. So we are having the fact that the minimum interior angle of a regular polygon happens to be the interior angle of an equilateral triangle, which is 60 degree, and the maximum exterior angle of a regular polygon happens to be the exterior angle of a equilateral triangle, which is 120 degree. So these are all the theoretical concepts that we should understand and remember, and of course the basic understanding of the polygons, how they look like, the curves, open curve, closed curves, the sides, the interior angles and the exterior angles, all these, and these results are important. Most of the problems will be based on the angles, exterior and interior angles of a polygon or a regular polygons. So in the next video, I will start solving the first exercise of this chapter, that is exercise 14a. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Please stay tuned for the next video, where I will solve the problems of the exercise 14a from the textbook of author RS Aggarwal. I will end the video here. Thanks for watching, and until the next video, take care and bye.